Today we're going to talk about how to find the area of a kite and a rhombus. And there's the same, it uses one equation. And what's important about finding the area of a kite and a rhombus is using the diagonals. And the reason is because the diagonals, if you remember back to studying those shapes, the diagonals of those two shapes are perpendicular. And we've talked about how our base and our height need to be perpendicular to each other. And since those pieces are the pieces that are perpendicular, that's what we're going to use to find the area. So the area formula for a kite and a rhombus is 1/2 of diagonal 1 times diagonal 2. Now, you may need to, if you want to, replace this. It's diagonal 1 times diagonal 2 over 2, right? And that little 1 and that little 2, those are just little last names, right? Diagonal 1, the first diagonal and the second diagonal is what it is. Okay, so what we're talking about with the diagonals is these two pieces. So that orange line times that blue line divided by 2. So if we look at this example first, we have that this piece is 56, and this other piece of the diagonal, I notice it's a kite. I know that I need the diagonals. It's 26, so that means all the way across, 56 plus 26. 56 plus 26 is 82, so we know that is 82. And then each of the other two pieces right here, this piece is 20 and the other piece is 20. And so this distance here is 20 plus 20, which is 40. So the area is diagonal 1 times diagonal 2 over 2. That's the formula. So I'm trying to find the area. So area is equal to diagonal 1, 82, times diagonal 2, 40, divided by 2. 82 times 40 divided by 2 is equal to 1,640 inches squared. So if you were going to wrap a kite, wrap a kite with wrapping paper or something, gift wrap paper, you would need to make sure that you had at least that many square inches, which it is sold by the square inch. If you look at it, it shows the square inches on your wrapping paper. You would know whether you had enough to cover it or not. So this is a rhombus. Number 2 is a rhombus. Notice how your diagonals, remember they were bisected, and they're marked congruent here, so it's easy to see. So that diagonal is 20 and 20. This other diagonal is 10 and 10. And since those are my pieces that are perpendicular, my area is diagonal 1 times diagonal 2 over 2. So my area would be diagonal 1, which would be 20 plus 20, times diagonal 2, which would be 10 plus 10, right? This was 20 plus 20. This was 10 plus 10 over 2. So 40 times 20 divided by 2 is 400, and it would be centimeters squared. Now on number 3, notice you don't have the diagonal. You don't have one of the diagonals. I have my 20 and my 20, but I need my other piece. Well, see that right triangle right there? Again, every time we almost have used it on every shape so far, we're going to use Pythagorean theorem. So x squared plus 20 squared is equal to 30 squared. So x squared plus 400 is equal to 900. Subtract 400 from both sides. You get x squared is equal to 500. And so the square root of 500, we would take the square root of both sides. X would be 22.4. So this is 22.4, and this is 22.4. So now we just need to find the area. So we got x was 22.4. So my area, that's diagonal 1 times diagonal 2 over 2. Well, diagonal 1 was 20 plus 20, which is 40. Diagonal 2 was 22.4 times 2, doubled, 44.8. The whole diagonal divided by 2. So 40 times 44.8 divided by 2 is 896. So it's 896 units squared, since I didn't have any units. Okay, now on the last one, notice I've given you the area. That means we need to use the equation, right? Area is equal to diagonal 1 times diagonal 2 over 2. So we're going to write down what we need so that we can go find it. So the area that I have is 126. So I'm going to replace the A with 126 equals diagonal 1 times diagonal 2. Well, I have AC. Actually, I have this as 12, but remember in a kite, that diagonal got cut in half, so that's 12 also. So that AC is 24, and I'm looking for BD, looking for this entire piece. So that's your diagonal 2. So we would have 24 times diagonal 2, and that's over 2. So you can handle this too a couple of ways, but the easiest way I see right now is to do that 24 divided by 2. So 126 is equal to 12 times D. You could multiply both sides by 2 and get 252 on the other side, but the 24 and 2 divided easily, and so 126 divided by 12 is 10.5. So that means that BD is 10.5, the whole thing. So for both a kite and a rhombus, you would use the equation diagonal 1 times diagonal 2 divided by 2, because the two diagonals are the pieces that are perpendicular to each other.